This is a video about confidence intervals, and we're going to calculate confidence intervals for two different population parameters. So a population parameter could be a mean or a proportion, which we usually talk about in terms of percentages. And so what we're doing, say we want to provide a confidence interval, not just a point estimate of a mean, then we're taking, if we're doing it for a mean of the whole population, the actual mean, we're going to take the sample mean and calculate a margin of error based on the formula below, and we're going to subtract and add the margin of error from that sample mean. In order to calculate the margin of error, we need two things, the standard error, and then we also need the critical value. So z for alpha divided by 2 is the critical value. So for example, if we want a 95% confidence interval, in other words, if we want to be 95% confident that the actual population mean is in between the two values in the interval that we create, that means that we're going to have in our tails of our distribution, we're going to have that 5% of our distribution is going to be split into these two tails. So we're going to take that 5% and divide it by 2, and that gives us 2.5% in each tail. So that's why when we do confidence intervals, the notation is the z-score associated with alpha divided by 2, because we're looking for this z-score here that has 2.5% of the distribution to the left of it, and this z-score here that has 2.5% of the distribution to the right of it. All right, so it's going to be the same process for the mean and the proportion. We find this critical value and we calculate the standard error, which we have learned to do previously, and we multiply those together and then add them and subtract them from the test statistic. Okay, so starting with an example for a sample mean, I put the formula for the mean of a sample in here just to remind you, but in a lot of these problems I'm just going to be giving you the sample mean already calculated. So in this example, the U.S. Census Bureau conducts a study to determine the time needed to complete the short form. The Bureau surveys 200 people. The sample mean, which is of the time that it takes to complete this short form, is 8.2 minutes. There is a known standard deviation of 2.2 minutes. That's not super realistic, but just for now, we're just assuming that we know the standard deviation so that we can use the standard normal distribution. And that is the z-scores, right? So known standard deviation means we can use the z-scores and the z-table. That's the standard normal. All right, so we're going to construct the 95% confidence interval. As we saw on the previous page, the if we have a 95% confidence interval, that means that alpha equals 0.05, which is our 5%, and so that means our z of alpha over 2 is z of 0.025. So our z of 0.025 is plus or minus 1.96. So this is going to be true anytime you are doing a 95% confidence interval. You don't have to write all these steps. You can just go, this is just FYI, you can just go straight to, okay, I know the z-scores that I want are plus and minus 1.96. So that's the z-score, and the sample mean is 8.2 minutes, and so then we need the standard error. So the standard error is the standard deviation of the sample distribution, so that's the standard deviation of the population divided by the square root of n. In this case, n is 200, and the population standard deviation is 2.2. So we're going to get this number by taking 2.2 and dividing it by the square root of 200. So I'm just going to do that off screen here on my calculator. So we have 2.2 divided by the square root of 200, and that for that I get 0.1556 if I round it. All right, so the margin of error is going to be that plus or minus 1.96 times the standard error, 0.1556. And so doing that, I get 0.3049. And so finally, now all I need to do is I need to take the mean and subtract the margin of error. So that gives me, the mean was 8.2 minus 0.3049. And so that gives me 8.2 minus 0.3049. That gives me 7.8951. I'm going to round it at the very end, and then I'm going to do the mean plus the margin of error, which is 8.2 plus 0.3049. So 8.2 plus 0.3049 equals 8.5049. So I'm just going to round these to the tenths place to construct my interval here. So finally, my interval is going to be 7.9 to 8.5. So that means that we are 95% confident that the population mean is between 7.9 minutes and 8.5 minutes, right? So this is the mu. Another way we can write it is mu is between 8.5 and 7.9. And we're 95% confident in that. All right, so that is a confidence interval for a sample mean. So let's see, it's the same steps for a sample proportion, but we just have a few different steps in order to calculate the standard error. All right, so in this example, a poll of 1,200 voters asked what the most significant issue was in the upcoming election. 780 answered the economy. We are interested in the population proportion of voters who feel the economy is the most important. Construct a 90% confidence interval for the population proportion. So you can look this up for yourself, but the Z of alpha over 2 for the 90% confidence interval is going to be a Z of 0.5, and that's going to be plus or minus 1.65. Right, so it's 90% means alpha. CI, 90% confidence interval, means alpha equals 10%, and then we divide that in half. Okay, so for this one, we're going to go ahead and calculate, well, let's say actually what x is. X is 780, said economy was the most important, and then n is 1200, and so that means that p hat is 780 over 1200, which is 65%, and q hat is 1 minus p hat, which is 35%, 0.35. All right, so to calculate the standard error, that is going to be the square root, right, looking at this formula right here, is the square root of 0.65 times 0.35 over 1200. So just doing that on my calculator over here. It's going to be a really small number. Okay, so we get this equals 0.0138, which is just slightly over 1%. All right, so to calculate our margin of error, we take our z-scores and we multiply it times that standard error, so 0.0138, and we get 0.0227. And then finally, all we have to do is take our sample proportion and subtract the margin of error, as well as take the sample proportion and add the margin of error. So the sample proportion is 65% minus 2% and some change, and for that we get 0.65 minus 0.0227, and we get 0.6273. And now we'll do 0.65 plus 0.0227, and didn't write that. Is 0.6727. Okay, so I'm going to round to the thousandths place. So that gives me 0.627 to, well, it's very symmetric, 0.672. And oftentimes we might present to the public, even though doing the calculations, we like to, well, the decimal usually is what works. Modern computers in Excel can handle percent notation. Back in the day, they couldn't. You had to convert it to decimal. So as a percentage, this would be 62.7% to 67.2%. So another way to write that would be that the population proportion, the actual percentage of people who would select the economy as the most important issue in the next election, is somewhere between 62.7% and 67.2%. So this is a 90% confidence interval. All right, and that's it for now.